Thank you, everyone. My name is Adil. I'm one of the co-founders of Split. And we are here to talk about the culture of experimentation. Our guest speaker, whom I'll introduce shortly, is Yashu, the head of experimentation at LinkedIn. A little bit about myself. I'm a, what's the word for that? The person who kind of like leaves a religion. I used to be a data scientist. I had that religion. I left it because I hated it, because I love data infrastructure. Because to me, data infrastructure is what makes data science possible. That's a little bit about my background. I've spent time at companies like Yahoo, LinkedIn, and RelateIQ, where I have dealt with problems in data science infrastructure, and experimentation across different sizes of spectrum, right? And all of those experiences led me and my co-founders, Pat and Trevor, to start Split. So a little bit about Split. It makes sense that we are hosting a talk on culture of experimentation because we are a feature experimentation company. The audience over here doesn't really, because you guys are all here specifically for experimentation, I don't need to describe or anything like that about experimentation. But the little bit I would say is that if I were to talk about experimentation, I would say that I would explain it from an analogy, which is I subscribe to the frog kissing theory of product development, which is simply that if you want to find your prince, you have to kiss a frog, right? And the only way then to find your prince as quickly as possible is to kiss as many frogs as possible and as fast as you can and not make a face. Product development is very much like kissing a frog because you don't know what exactly will work. By the way, you won't find a quote like that in the very professional talk by Ya. You can only find it in a talk by me. Product development is very much like kissing a frog because you have to find, you have to constantly develop features and ideas, turn ideas into products, and see what moves the needle on customers. And the only way you can do that efficiently is if you do it fast, you do it often enough, you do it safely, and then you measure. You measure if you're finding your prince and you're delighting your customers. So that, to me, is the essence of experimentation. Our speaker tonight, again, is Yashu. A little bit about her. She is a statistician from, she got her PhD from Stanford. After that, she worked at Microsoft. She interned at Google. She worked at Microsoft for a significant amount of time. And then she joined LinkedIn, where I had the honor of working with her for a little bit of time. But then I've gotten to know her a lot more afterwards. Over there, she heads experimentation, platform for LinkedIn. If you think about it, these companies, Microsoft, Google, LinkedIn, if there was a Voltron of experimentation, those would be the lions and she would be the head. But, so she's the best speaker that we can have on this topic of cultural experimentation. With that, I'm going to hand it over to Ya. So.
Thank you for the nice introduction and for the challenge that I'm not going to be able to tell the same good joke that you can tell. We'll see. Okay, so great to see this crowd. It's always great for me to speak to experimentation and enthusiasts outside of LinkedIn, right? Outside of other companies as well. So. Feel free to interrupt me with questions whenever you want. Just raise your hand. I like that discussion, the flow going forward. So today I'm gonna be talking about how LinkedIn's experimentation grow in the past 7-9 years, essentially, and then sort of see where we are today, right? What it takes to get there. So I assume that everyone have heard of LinkedIn. Right? If you haven't, you should go linkedin.com and sign up. So basically at LinkedIn, we have this vision that we wanted to create economic opportunity for every member in the global workforce. And in the past several years, we have actually gained a tremendous traction. And today we're looking at almost actually over 500 million of members on LinkedIn and over 10 million companies and jobs at LinkedIn as well. So experimentation definitely has played a tremendous role as the company grows in the past 10 years or so. I don't think I need to introduce the experimentation concept deeply to this group of people, but I mean, the concept is very simple, right? We have 2 versions of the site, and we wanted to see which one is better. And we do that through the real users telling us which one they like it better. So one thing that not everyone know is that pretty much all the big companies that's out there in the industry, they really value experimentation. They run experiments a lot, right? So what I'm showing you here is actually a study that is done by Brooks Bell, who runs a company that essentially does experimentation consulting. And if you haven't noticed that already, LinkedIn is on the top of the pyramid. And so, so to be honest with you, to be frank, I think LinkedIn is the very top of the pyramid because we are probably the only company with a logo that's small enough to fit in there. But we definitely have earned our position and earned to be among what she calls a level 5 companies, right? Together with Google, with Facebook, with Bing, Netflix, etc. So how do we get there? How do we get there? The way that I'd like to look at it is actually taking a look at the very famous other pyramids, the Maslow's hierarchy of needs, right? So what Maslow basically says is that when we're thinking about how we perceive in our life, we tend to satisfy the more basic needs first, right? And then we kind of go from there up. And that is exactly how, if I'm thinking about the experimentation program, sort of progress over the years, that's exactly how we did. We started out building trust, which is the most fundamental thing. And we finally kind of go one level above and then eventually reach what we call, at this point, that is, we are building an intelligent platform. So, and I'm just gonna kind of walk through the journey with you. So in our early phase, actually, we started out building trust, and turns out that it was probably the most challenging aspects of this whole thing that we did. And it took us 4 years. The whole thing that took so long is because it literally, you needed to go from design to deploy to analyze every single step of when you are running an experiment. You needed to make sure that you are trustworthy. And it wasn't like that when we started it in early 2009. So this was how we ran experiments back in 2009. Adil probably remembered some of it. So basically, if you are a member, so we have a member ID for every member who register with LinkedIn. So if you are a member whose last 3 digits of your member ID happen to be between 0 and 99, then congratulations. Then you are pretty much in every single new deployment, new features. You are our beta user all the time, all right? So what it makes it even worse is that now all the experiments are actually clumped together. They're confounded with each other. You can't even tell them apart. So if you have a bad experiment or a good experiment, it's all mixed up with other people's experiments that are running, right? So not only that, it was a process nightmare to actually set up an experiment. Here I'm actually showing you an email that essentially was a negotiation process between a group of people who is saying, okay, I'm going to take mod range 1 to 99. The other person say, wait, you cannot do that because somebody else is taking that, right? So as you can see, it was a process nightmare. It also, from our infrastructure standpoint, it took days to just deploy a mod range change, because every experiment essentially is defined by a text file, and that text file needs to be copy and pasted to every single services that this experiment touches. And deploying an experiment essentially means you have to deploy every single services, right? Just imagine even this would take days to do. Even if you did it, end of the day, you're not gonna get a statistically correct results because everything are confounded together, right? So we realized that. Started in early 2000, we finally built what we call LIX, stands for LinkedIn Experimentation, which is a real engineering solution that is able to run orthogonal experiments that centralized all experiment definitions as well. Now from defining to actually activating an experiment literally takes just 5 minutes, right? So which was great. And it turned out that LIX actually, I would say, when the initial motivation was for it to run experiments, but it actually also became a very fundamental and essential piece of LinkedIn's infrastructure for just how we deploy our changes to the site in general. Okay, so now we have the experiment is designed and set up, right? And this is how we were looking at the results from experiments, right? Every day the data get dumped into a spreadsheet. Good luck actually understanding all these numbers. It actually took us quite a long time, almost 3 years, to realize that we actually needed a UI to interpret results coming from experiments, right? What's the point of running an experiment if you cannot even analyze it or interpret the results, right? So we put the numbers behind a UI, but now that we can actually tell what the numbers mean, we start to be like, wait a minute, it doesn't make any sense. We have experiments that had 50% impact on users on one day, and the next day they would have a negative 50% impact on the same group of user, right? So it turned out that we were wrong in the way that we were computing the numbers. We were wrong in the way that we were computing statistical significance, right? So I know that there are some statisticians in the group, so I was gonna tell that joke. So we started in the way that so we wanted to compute, obviously, in order to get statistical significance, you will need to compute variance, right? And so the team at the time, we were looking at how to compute variance, and the team knows for Bernoulli random variables, you compute the variance by what? P times 1 minus P, right? But what if the metrics that you're looking at were actually page views per user? That is a greater than 1 number, right? How do you do that? So the team got creative, and then so instead of using the right variance computation, it was like if we invert the page views per user, we can turn a number that is greater than 1 to be less than 1. That can be a probability, right? So you can see that like it was tremendously important to actually get the numbers right, because then when you're looking at not just the statistical significance, but also just even the simple calculation as well. So finally, it took us a year from there on to actually realize the importance of getting the numbers right, and that's where we actually started introducing what we call Excellent, which is a combination of the LIX component of it and also the UI, where you can interpreting experiment results as well. And then with the correct statistically valid computation with a nice UI where you can actually easily drill down and understanding the daily trend, now becomes, the results become very transparent to whoever runs the experiment. And then for people who are not, doesn't have to be statistically savvy anymore, right? Like all the PMs and engineers who can read these dashboards easily. Okay, so that brought us then to the second stage of our journey. So now we got more people to start to run experiments, but there are even more teams who are not, right? So in order to actually have a lot of teams to start running experiments, we needed to, number one, obviously, we need to scale our infrastructure such that we can actually handle like hundreds of experiments. And the more importantly, actually, from cultural aspect, we realized it was really important to be able to build our platform such that it's as self-serve as possible. Anybody with a limited knowledge are able to set up experiment, can actually run experiments, right? What's even more important is that you needed to start creating a common language on metrics such that when people are talking about the impact experiments, they can easily translate in between product development teams, even to the finance teams, to our financial output, like financial outlook going forward as well. And I'll share what I mean by that. So, so first of all, we created a what we call UMP, Unified Matrix Platform. Essentially defines the common language that we use across matrix, right? It has 5,000 metrics that's computed every day, and it's growing, right? Essentially, this becomes the single source of truth around how we are talking about the impact that we have, right? Not just people running experiments, but for executives who are looking at numbers day over day, year over year trends, they're looking at the same matrix definition as well, right? It also became very, we made sure that those metrics are super easy to be onboarded as well, and that's how and then once your metrics are onboarded into the platform, you don't have to worry about the operability as well. So that's how we actually started to gain traction of having people to get their metrics into the platform. So we also defined what we call essentially the difference between triggered impact and side-ride impact. So when we run experiments, a lot of times when you're looking at the experiment impact, it's actually limited to who you are targeting, right? I can run an experiment in the US, or I can run an experiment targeting students, right? And then even if I'm actually having session improvement on students, that's like 100% improvement, that doesn't mean that it's going to bring 100% improvement to your business, right? So what we did is at the platform level, we actually translated the triggered impact that you saw for your experiment to the impact that this experiment would have for your business if this experiment were launched to 100%. Right? So with that, it became extremely powerful, because now when teams, individual product teams, when they started to run experiment, they can easily point it to it and say, hey, look, like I actually contributed 1.8% total sessions for our business. And back when LinkedIn was still a public company, we would actually then bake this number, our finance teams then would actually bake this number into our financial or our engagement, user engagement forecast or outlook that we public to the Wall Street as well, right? So so that's why having sort of this common language becomes really powerful and important. So with that, right, we started to really see a lot of growth, not only just in terms of the number of metrics that we have, but also the number of experiments that we ran as well. So I only have this until about a year ago. So we saw that we really grew from running about 200 experiments in mid of 2014 to running over 500 experiments just in 2 years' time. Okay, so now that we've got pretty much every single team and every single product launches going through experimentation, we started to realize that experimentation became a bottleneck in terms of how fast we could innovate, right? And this is why, right? So imagine that you actually activated your experiment on Monday, right? So first of all, we spent a full day just accumulating data, right? We only were looking at daily results. So if you activated your experiment on Monday, we wait Tuesday, entire day, just so that we can collect enough data. And then we would then start computing, right? The data started to flow from the tracking events to ETL, to aggregation, to metrics, to joining and everything, right? And the whole process started on beginning of Wednesday, and it will take 28 hours, right? So basically, you won't be able to see your first report for an experiment that you activated on Monday until Thursday, right? Obviously, as you can tell, it's a, number one, it's a risky thing because I could have kissed the wrong frog, and I didn't realize that until Thursday, right? And in a week, I can only kiss one frog, right? That obviously is not agile enough for us. Is that good? Okay. Okay, so then we spent a lot of effort, doubled down on how we were improving our computation engines, and then we were actually able to reduce that 28 hours to 8 hours, right? That obviously tremendously improved how fast we were able to process our experiments, and then increasing the speed that we operate. What's even more is that we started to thinking, hey, why does it have to be a day, right? We started to actually get faster data, so we go into intraday, go into sort of hourly reports as well. Obviously, we all know that hourly reports has a limitation of how much data it has or how much power it actually has for you to identify the true impact from that experiment. But what we use these hourly reports for are such that we are safeguarding, right? Just so that we're not getting into risk that we didn't anticipate to get. Okay, so now everyone is running experiment, and we can get our reports fast enough. What's next, right? So what we realize is to really solidify the culture that we have around experimentation. We really needed to make experimentation pretty much part of everyone's daily activity, right? It's like a social event. You get together, you talk about it. And it's like your daily routine. It's part of everything that you do. So what we did is we actually had this, I consider one of the most successful feature that we have, which is what we call most impactful experiments. So now imagine that you are an executive on the team, in the company, right? You have the teams running hundreds of experiments every day. And you have no idea how they are doing, right? Or let's say you are a team leader, and let's say you are on the profile team, and you are responsible for driving up number of people visiting the profile page, right? And guess what? There's 500 other experiments that could potentially impact your metrics. How do you know that, right? So what we did is we built this powerful feature where you can essentially sign up to follow any of the metrics that we have in the UMP platform, right? Then every week, we send you essentially a digest email of these are the top experiments that are impacting the metrics that you care about, right? Then you have obviously all the way up to our CEO who interested in this top line, really important metrics for the company. You got people who run our flagship who follows a different set of, maybe a broader set of metrics that's flagship focused. And you have this messaging PM who follows, the messaging metrics. So everybody in the company would have visibility to any experiments that's impacting the metrics they care about. So in addition to that, if you are actually running an experiment that is impacting important metrics for the company, we can also block you from ramping up, right? So essentially, when you are ramping up an experiment that is impacting a metric that's an important one, we actually force you to start having a conversation between your team and the owners of the metrics, right? And then if the conversation, if the owners of this metrics are like, okay, this is a really bad experience, you can't ramp the experiment up. So it become like a really powerful way of sort of forcing that conversation to happen across teams as well. We also made it super streamlined for you, right? If you are having an experiment, you can say, instead of go to the web portal and then see the results on the web portal, we can actually deliver the results to your inbox, right? So you can see that we have all the results, and then we just sort of send it to you in your inbox, and you can subscribe to get an hourly report, or you can be like every day, or maybe every day the first week, and then every week from there on. So in addition to that, we are also actually revamping our user experience because we started to realize people are not just using our platform to do experiments only, right? You started with experimentation. Once you finish you get a readout on your reports, and then you just wanted to utilize it to ramp it up, right? Because maybe you're concerned about your infrastructure is not necessarily able to handle the extra query that it comes in, right? So you just wanted to do it slowly in a safe fashion, right? And then once you reach 100%, maybe you just wanted to stay there because you are actually targeting maybe French speakers, and you just say, hey, I wanted to keep that experience for French speaker, that they all see this different from the rest of the world, right? So we are bringing those all experience together, and that's why we're kind of rebranding our platforms to be T-Rex, because it's targeting, ramping, and experimentation. Okay, so fast forward to current, we are talking about now. We started to realize that we really are at the point where we need to make our system more intelligently, right? So specifically in terms of how we should be guiding people when they are looking at the experiment, instead of having a data scientist sit right next to them and then interpret the numbers for them, we wanted to build the data scientist's brain into the platform directly so that everybody can be as experimentation savvy as a data scientist. So as an example, as I mentioned earlier, when we run experiments, it's actually not as straightforward of, hey, let me run an experiment, and then let me ramp that experiment to 100%. The goal, obviously, is to ramp to 100%, but the process is actually multi-stages, right? So we would, for example, here, I would start my experiment at 10%. Maybe I keep it there for a few days, and then I will ramp it up to 25%. I keep it there for another few days. Then I ramp it to 80%, and I keep it there for some days. And then I ramp it eventually to 100%. And then, so the way that people does it, there's no governance around that, right? There's no guidance around that either. So we actually did a data pool of how many different ways that people were ramping up their experiments, and it turned out that there were over 300 different ways to ramp an experiment to 100% in 1 year, right? I'm not even talking about how long people stay at each of the ramp stages, just the way that they were ramping, right? It was over 300 different ways. Obviously, not every single one of them were optimal. So then we started to introduce this, what we call SQUARE framework. Essentially, SQUARE stands for speed, quality, and risk. Essentially, try to answer the question of how can we go fast while controlling risk and improving decision quality, right? And the ways that we are introducing a ramp recommender, which essentially at every stage of the ramp, we recommend you what ramp percentage should you go up to, and on top of it, how long should you be staying at the ramp, right? And recently we actually just take it even one step further and saying, okay, why don't you just tell us how risky is your experiment and what sort of a magnitude approximately, is it gonna be impacting important metrics or not, right? Then just let it automatically ramp up, right? So that's where we are today, is that we are actually able to automatically ramping experiment up without human intervention. Okay, so one other thing in terms of where the intelligence platform really means to us as well is this automatic insights, right? It goes back to when I say, you essentially having a data scientist built into this platform directly. And we would, this is something that we have some of these features already built in, not every single one of them. For example, right now we have something we call burning feature. So I don't know, how many of you have heard of the terminology burning? Okay, so essentially when you run an experiment, the impact that you measure for this experiment can decrease or increase over time, right? For example, if I put a very shiny button on Google's homepage, I'm sure, like, a lot of people in the first few days would just keep on clicking and you'd be like, what is it? What is it? And after a few days, you realize it doesn't do anything. You will stop clicking on it, right? So the CTR, the click-through rate on that button, obviously is extremely high in the first few days and then dies down, right? So that's what burning means. And we realized, actually, a lot of our experiments have burning impact. So we started to build in to the platform in the reports directly to tell you, hey, watch out, your experiment actually has a burning effect. So maybe you should keep your experiment running for a few more days until it stabilizes. Right. Then other things, for example, is what we call early indicator. Right. You can have an experiment that is running, and then a lot of times people are like, there are certain metrics that has high variance, and so as you're running an experiment longer, you obviously will accumulate more samples, and then usually those variance will drop, right? But then if you can actually identify some early indicators for those high variance metrics, then you can actually terminate your experiment or make your decision sooner, right? And a very typical example would be revenue, right? Like revenue in general, revenue per user is a very volatile metric, because it's a very sort of zero inflated metric where a lot of users don't click on the ads, right? And then the people who click on the ads, if they click on it, usually an ads is like expensive, right? So you can have a very skewed distribution that would essentially makes the variance extremely high. The other one interesting insights would be actually what we call heterogeneous treatment effect, right? Your experiment could be impacting people who are in the tech industry very differently from how they impact people who are students, right? And you wanted to know that, as you are, especially as LinkedIn is a very internationalized, we have a very internationalized member base. Then a lot of times when we ship some feature, we don't quite realize, hey, wait a minute, people in India actually is impacting them a lot because, maybe they have a slower internet speeds and stuff like that. Okay, so that is pretty much the sort of where we are in terms of the journey that we have taken, right? So I just wanted to sort of concluding my talk with a few of those experiments that we ran, just kind of give you a sense of the kind of experiments that we would do usually. So this is actually a fairly old example. So if you use LinkedIn often, you probably have realized that the UI is different now. So back in the days, we have ads on the top. We call it profile top ads. And then if you click on the ads, we make money, right? So this is so we were tracking essentially CTR on those ads. And this was what the chart looked like. So basically started one day, that all of a sudden we started to see a huge drop on the CTR. And obviously, if you're not familiar with the metric CTR, if we have less CTR, then we have less money, right? So obviously the team started a war room, started to investigate and try to figure out what went wrong. And what do you think went wrong? Go ahead. A book? Anybody else? Burning.
Burning. Is that what you call it? Burning.
Burning. Yeah. Anybody else? Bad campaign. All good guesses. All good guesses. You were right. It was actually a bug. And the bug was so subtle, literally what it does, it removed 5 pixels between the navigation bar and the top ads. And that 5 pixels cost us a lot of money and a lot of energy and a lot of chaotics for people to actually figure out why. And then this was actually a counterexample of we actually deployed it without experimenting it. And that's why we didn't catch it. That's why it was actually a very massive impact. That's why it took us days to figure out what went wrong, right? And this was an example from the early days, right? And then now, of course, everything was experimented. So the second example is another example from our profile page. Is actually, we call this essentially tell users why, right? So this one line on the bottom, is where we tell people, hey, why should you actually list this kind of information on your profile page? And what we didn't realize is such a small change, just telling our user why, was actually increasing our profile edits by 14%. If we didn't experiment, we probably wouldn't have tried it. If we didn't have experimentation, we probably wouldn't have tried it. So, some bigger changes, right? So this is actually a redesign of our payment flow. By redesigning it, we were actually able to have a 30% reduction on refund orders and millions of dollars in booking. Finally, it brought us to the most recent massive experiments that we did, which is a redesign of our desktop experience, right? So as you can see there, we literally redid our, this is our new version of our desktop, the look and feel, and this is the older version, right? Not only that we put it under A/B test as sort of the overall tests, right? We also had done many like the local A/B experiments within the new experience as well. So for those of you who have any feedback on the new design, you should come and talk to me as well. Okay, so that pretty much concluded my talk. I also have in the back of the end of the slides some of the papers that we had. Actually, a lot of it was the materials that went into the talk as well. Okay, any questions? Thank you. Thank you.
Let's hold the questions till the end because we've got Miguel, one more talk.
Okay.
So before I introduce Miguel, one of the things that, by the way, I really introduced about the examples, I really appreciated about the examples is from our customers as an experimentation company, one of the things we noticed, especially people who are early on this journey, as opposed to LinkedIn, one of the biggest cultural problems that we deal with is hubris and laziness, right? Where a lot of teams, a lot of people who are trying to create the change of experimentation within their company, they run across people who are like, well, we know what's best for our customers, right? And then the other thing people run into is laziness, which is, hey, we don't have time to build A. How are we going to build A and B, right? Those end up being like common problems. And so the best way to solve those problems is by some simple, if you can push your way, force your way into getting one or two examples out where you show how your intuition was wrong or the hubris was wrong, you're able to then affect a change. So thank you so much for that. I want to introduce Miguel, our host, and I believe Colin's also talking with you. They're going to give a quick talk about VEVO and experimentation.
Cool. Thank you. Thank you, everybody, for coming tonight. I hope you're enjoying this. Thank you for the fantastic talk. It was very good. I want to talk briefly about VEVO. Let me ask you a question. How many of you have seen the VEVO logo before? Raise of hands. How many of you know what VEVO does and what we do? Exactly. Okay. So just to give you a little synopsis, so we are the leading music video platform, the world's leading music video platform. We're actually owned by two of the three major record labels, Sony, BMG, and Universal. We have owned and operated properties in the form of like VEVO.com, also mobile apps and TV apps. But we also have presence in syndicated properties such as YouTube. YouTube is the biggest syndicated presence that we have. That's probably where you've seen the VEVO logo before. Just a little bit of data in regards to the scale of VEVO, just to give you a rough idea. So we do across all of our properties, owned and operated, as well as syndicated, around 24 billion video views a month. I'm not going to go into all of these, but a couple other interesting things just to show how pervasive music video is today. If you look at Rihanna, when she released her music video work, she reached 8.8 million unique viewers during that premiere. If you look at TV ratings, if you look at the standards of TV ratings, that puts her really one slot below the Oscars and one slot above Walking Dead. So that's huge. Then another example, when Justin Bieber launched Baby, his music video Baby, It took about 4 years to get to a billion views. Fast forward a few years later, Adele releases Hello, and it took her 88 days to reach the same 1 billion views. So clearly, music videos have become more and more pervasive over the last few years. So that's what we've been doing. That's what VEVO is today. Now we're testing new territories. We have this new thing that we're calling VEVO Live. It's really about connecting the artists and audiences closer to each other. There was a little bit of experimentation. There was a little bit of frog kissing to get to the conclusion that this may be something to pursue. The gist of it is the ability to have a live event with an artist that is hosting the event. The artist is sharing a playlist of music videos, and then there's the ability for audiences to connect with the artist via chat window. That's basically what we have today. We did a pretty big one a few weeks ago with Fifth Harmony. That's the biggest that we've done so far. We're actually going to do another one this Friday with Demi Lovato. We got some really good results from that one that we did with Fifth Harmony. We got around 3.2 million views while the event was going on. Bear in mind that one of the special things about this is that we are broadcasting in multiple platforms at the same time. Owned and operated, YouTube, Facebook, we did Twitter with this past event. I think for the next event, we're gonna add Instagram as well. So, you know, the idea is that it's an omni-channel kind of product. So this is a little bit of the feedback that we've been getting. Lisa DeLuca from Epic Records, myself, management, and the girls all are extremely happy. That's from the Fifth Harmony event. Sheila Hosbury from Maverick Management, who manages Fifth Harmony. Thank you for everything today. I appreciate all the love and support. So the labels and the artists are really, really loving what we're doing. It's a very, very exciting time at VEVO. I think we're gonna go into some interesting territory in the next year or so. And we're also hiring. So if any of you are passionate about music videos, technology, data, experimentation, machine learning, this may be a home for you. Now I'm going to pass it on to Colin and Reza to go into a little bit more of a technical territory.
Thanks, Miguel. Okay, so the title of my small section is Experimenting at the Edge of Your Control. Senior data scientist, been here about 9 months, loving it. So this talk is really about kind of non-canonical experimentation, because you can't always own and operate and have complete control over your platform like at LinkedIn. And sometimes you have to do things a little differently. So we have, like Miguel said, our own owned and operated platform where we got rich user level data. It's complete end to end, but it's smaller than YouTube is in general as a platform. But it is focused on music videos. So we do a lot of experimentation there, and Reza will talk a bit about some of that. Similar, though smaller in scale than at LinkedIn. We don't have as many data scientists and engineers, right? But what I'm going to talk about is a little bit of what you can do when you don't own everything. So there's an opportunity to be had on YouTube, right? There's a huge audience. And one of the things that we're always looking to do is increase the fraction of time spent that's on YouTube going to VEVO videos. And lots of people have opinions about how you could do this. We have a whole creative team that likes to does various curatorial work. People from the artist teams, the labels think they have, this is really gonna drive more views. But can we do experiments here? And so we had one outside company that said, hey, we think we can do a better job. And so we're moving forward with an experiment where basically we're going to try to control and see if they have a measurable effect in a real experimental condition, as opposed to just letting them run wild, right? And so on an owned and operated platform, you can do things like change features or copy your layout or algorithms or pretty much everything. But if you're going somewhere like putting your content out on YouTube, they own the platform and the user experience. So you can maybe influence the algorithms with the metadata that you have. But really, what you've got is what they allow you to change. And in our case, it's mostly about metadata. So where this really becomes a bit more non-canonical is most of the time I hear people talking about experiments, and the experimental unit is never really brought up. It's always essentially implicit that it's always the user is the experimental unit that you're randomizing across. We can't do that here. But what we can do is randomize across various kinds of entities that have various metadata, like videos. We have 300,000 videos on YouTube. We've got 60,000 different channels from different artists and different collections. So we're going to randomize across one of those instead of across users. So we'll give, let's say we'll send 1,000 channels in a control group and 1,000 channels in an experimental group. And we'll change anything like the banners or thumbnails, home rows, add playlists, change keywords to see if we can affect search relevancy and recommendation relevancy. In the same vein, we really can't directly modify the content itself. The artists put their blood, sweat, and tears into this, so we can't really change that, but we can change things to influence various factors about the platform. This is not necessarily an easy process. It's actually probably a lot harder than it is to experiment when you have complete control over the ecosystem, and it really requires you to rethink a lot of things, especially culturally, when you say, well, let's just do what we can. And also when you're working with outside companies and people who aren't used to experimentation, not engineers, not data scientists, there are definitely there's a lot of trust to be built. So a couple just quick tips for success about this. It's super important to clearly define those goals. What, for whom, and when will you deliver results? Start small. So we've got 60,000 channels. Let's not try to do all of them. Let's just isolate to a few and see if we can demonstrate success and build that trust and move up that pyramid. I'm definitely going to steal that, by the way. That's great. And then sometimes you have to be scrappy about measurement because you don't own all of the factors of production, as it were, and you have to actually kind of suss out what you can, use APIs where available, et cetera, right? So yeah, that's a little bit, and I'm happy to talk more about what it takes to do that and to talk a little bit more about the ML on our owned and operated platforms. Reza.
Thanks, Connor. Hi, I'm Reza. I lead our machine learning efforts here at VEVO, and I wanted to quickly walk you through some of the experiments that we do to improve our machine learning products and services. So the objective here being obviously improving machine learning system performance. Now, if you're in the machine learning practice, on a day-to-day basis, you have, for example, your model that you have the set of your data that you want to train your model on, and you want to make sure that your selection of model, your hyperparameters, your model parameters are generalizing well, or, for example, providing the right accurate predictions, for example, increasing precision, and so on. Now, that's all great, and you might have spent a lot of time working on that, but how are you affecting product level success metrics? This kind of goes back to the site-wide metrics that y'all talked about, that you can put a lot of effort on tuning and optimizing your models and algorithms, but then if you're not really having a statistically significant effect on your watch time, which maybe you're optimizing for, or your engagement metrics, or your product metrics like your daily active users on your monthly active users and so on, then you might not be moving the needle as you want to. So to give you a bit of a context before talking about the experiments, our machine learning recommendation system architecture at a very high level is based on a neural embedding system where we use offline processes to train those neural embeddings, and then we have a search ranker recommender system, which then, for example, finds similar artists, similar videos, and provides the playlist or stations or artist recommendation system service where our client apps use. And then obviously we collect events from the application so that then we can do these type of experimentation studies and see how well we're doing. One experiment that we recently ran based on a new service is actually related to two different stations experience generated from our ML service. The one on the left, the mixed stations, is about, and both of them are, they're Queen station, so the main artist there is Queen. The left one has a bunch of videos that are Queens and also related, but also you see like on the second item, there's Justin Bieber. Now, if your user and the system has determined that you also like Justin Bieber, but you're recommending that within an artist station, is that a good thing or is that a bad thing? Like, how would that affect your product success metrics? Versus on the right side where you have a focus station, and as you can see, like everything there is relevant to your preference, but also very, very highly focused on the main artist of that station. And so this is a classical example of an A/B test. Basically, the way that we're implementing it right now, we have our focused ML stations and the mixed ML stations, and we have our basically experimentation treatment router called switchboard, which is using split IO to split on users in this case. And then we'll be able to measure, for example, how well we're doing on, or if we're, if in terms of statistical significance, does any of that matter? Does, and higher than that, what would be the difference, if at all, between the two services? Another example is, again, a newly feature that we launched, Your Jam, which is our first generative, what we call a playlist, which our ML playlist service provides. And that creates a complete playlist with videos based on a user's preferences. And prior to that, the service that we had was a playlist recommendation service, which recommended playlists that were curated by our curation and content team. So in this case, we want to experiment, okay, this ML-generated playlist, is it statistically, in a statistically significant way, moving the needle or not? And for this, a classic treatment test where in one experiment on top, Your Jam ML, we have the playlist cover image with the generative content. And then we have a placebo item where the cover and the name and image, everything is the same, but the content is basically a curated playlist. And then we have the control, which is the service without Your Jam. And again, using switchboard and split IO at the front. Now, we don't have results yet, so if you're interested in the results, reach out to us, to me, and we'll be happy to tell you how that went. But really, in this case, online experiments versus offline, where you're looking at improving, for example, your test data set performance. In this case, it's about that site level, as Jan mentioned, effect, how you're affecting that system level, how your system level performance is affecting your top product success metrics. And also the effect of your lower level variations. Every effort that you're putting in improving, for example, your models or collecting data and all, how is it affecting there? Thank you.
Thank you, Rosa. Any questions for Ya or any of the VEVO team? Go for it.
The question is for Ja. It's how do you manage to avoid confounding effects along all the experiments, given that you are automating a lot of them?
Yeah, so we actually, this is what we call like orthogonality. So essentially, the chance of you being in treatment for one experiment, like if you are in the treatment for one experiment, the chance of you falling into treatment or control are equally likely, right? So essentially, this is what we call orthogonality. So unless the two experiments are actually what we call interference in each other or interacting with each other, that you can analyze them independently. And then we actually have done study, and this is actually true for both my experience at Microsoft and at LinkedIn, when the chance of two experiments actually interacting with each other is actually fairly unlikely. It's actually very unlikely given the number of experiments that we run. Right, so just give you an example what I mean by interaction. So let's say you like ice cream, right? And then so if I give you ice cream, you're like, yay, right? And then you also like garlic, right? But if I give you garlic ice cream in combination, you may hate it, right? So the effects coming from ice cream and the effect coming from garlic, they're not additive. That situation is actually really rare in the kind of experiments that we do. I think largely also because we And we have so many entry points into our product, right? And then people are interacting, like you can run experiments on profile page that probably has nothing to do with, or very little thing to do with the experiments that you're running on the feed page. Yeah? So they're not really interacting or interfering with each other.
And this is a question for you and you as well, so both, depend on which direction we can go. So I'm Cindy, I'm from Ancestry.com. I manage the product analytics and customer analytics there. So through the company, Ancestry have using many testing tools, experimentation tools. So there's test target, there's a homegrown system, and there's a mixed panel, depending on the client side, we try to test, our service side, we try to test, our mobile app, we try to test, our website, we try to test, right? So I try to make a change, which is I only want one tool. So I can see that one single user, how that impact through the whole life journey, right? And I read your paper and super inspired by it. But the first question I get from management is, let's evaluate it buy versus a build, right? So the first question I have is, to solve the case I have here, is there a tool out there or testing solution out there I can already use to run all those cases, right? One tool. The second question is, if there's no such tool, if there's no, great. So if there's no such, if there's, great, I want your paper. Thank you. If there's no such tool, obviously there is. How do I make a strong case to make the management have that commitment to building up a homegrown system? Because it's a long-term commitment here, right?
You want to take it or you want me to take it?
We can both take it. I'll just say a few. I mean, I won't take too long. A couple of things. I think like a lot of the system. One of the reasons why you have a plethora of systems that you have to rely on is because historically this is viewed as A/B testing. And there's plenty of tradition of A/B testing. A/B testing tends to be kind of like thought of as a marketing concern. So that's why you've got tools like Adobe Test and Target. You're probably familiar with Optimizely as well. And it's just that over the last 5 years or so, I mean, this is from my experience at LinkedIn and before that at Microsoft and Google, there's been a real shift towards this experimentation becoming an engineering and product concern. So there really is a dearth of products out there that satisfy the needs of a product engineering team. And the reason why you're having a little bit of trouble is because you're looking for a tool outside of the company that's meant for use for your engineering and product teams, not for your marketing teams, right? And when we talk about something that's built for developers and product managers, that's something that's very different in the sense that first of all, it's supposed to be full stack, right? For example, Adobe Test and Target and those tools don't end up working over there. So whether it's deep in the back end or in the mobile or on JavaScript or on the web front end, it needs to work all over there, right? And not only that, the type of metrics that it needs to deal with is not the clickstream metrics that we tend to associate with basic optimization tools. So there's a real dearth, and that's why Split got started. I mean, so I don't want to speak too much about it just because I want this to be a neutral space. But that's the whole reason why we started it. Now, in terms of build versus buy, you can definitely build it. Takes a long time. We've been at it for like 2 years. So it will take you a good amount of time with a dedicated effort. You can definitely build it, but it takes a significant commitment on part of the management team to build it. So.
I definitely want to second that. It does take commitment. And I think a lot of it, like from my experience at LinkedIn, it was actually a lot of very strong support from the leadership. It tends to be very challenging to be bottom up, to build an experimentation culture, because the executives, they need to be in all these product reviews, in all these launch reviews to be like, hey, well, how did this move the numbers, right? So I think also kind of again built by, I think it's really a lot of it has to do with what is the scale that you guys are looking at. I think certainly to kind of like, get into a early wins and then say, hey, what is the experimentation can benefiting and like can benefit the product development that you guys have. I think I would say go is buy, and then once you demonstrate that, and if there is like such a strong need, and you're like, okay, I'm actually going to be running 100 experiments concurrently and like every month, then that is probably or even before that is probably times for you to start thinking about obviously how much it costs you, and then what if you just have a team on your own, and then scaling that it would be more logical at that time point.
So a question about building the data scientist into the platform, because that's something that we've talked about quite a bit, trying to do that, right? Because it's only one of me and a couple other data scientists, right? But there's so many people who, once they see the power of experimentation and the analytics in general, they're like, oh, I want that person. And how have you been able to translate that? Has it been successful? And one thing I thought about while I was seeing your insights section was, how does the impact of multiple comparisons weigh into that when you have people having the option of choosing to look at multiple metrics or not, or they might peak or stuff like that. So how do you build those sorts of things in, or have you even tried?
That's a great question. So obviously, to really replace our data scientists is it's aspirational, but I don't think it's ever possible, right? So as the philosophy that I have for the team is, as much as we can, let's automating the insights that we have that is generalizable across experiments. And then several of those insights that I shared today are of those nature. So what we have done so far is essentially pretty much what we have achieved so far is pretty much a majority of the experiments that we run. We don't need a data scientist to handhold our engineers or product managers to actually interpret the results, right? So we have sort of done a good enough job, I think, from both the education from our data scientist aspect, and also the way that we're building our platform to be as accessible as possible, that people are very self-served, right? So going back to your specific question in terms of let's say multiple testing, it's actually, I learned my lesson in the way that I think statisticians think very differently from the rest of the engineers or the product managers. Sometimes it's really about, it's not so much about let me be as accurate as possible, but it's actually how can I get to 80% right, but as intuitive as possible. All right, to address the multiple testing problem, the way that we did was actually not say, hey, how can we maybe build one of those multiple testing adjustments into the way that we're looking at data, which becomes either too conservative or too aggressive. What we did is actually saying, okay, instead of showing you all these 4,000 metrics, and then obviously by nature of p-value, you will see 200 of them being significant. We said, okay, why don't you tell us your success metrics, right? And your success metrics would be probably order of 10. So multiple testing for 10 metrics is not a big deal, right? So that's sort of the way that we approach the problems when it comes to sort of intuitive, making the results as intuitive as possible. Does that make sense? Answer your question?
For those of us who don't have 400 million members, what advice do you have?
5.
Right, sorry, 500 million. What advice do you have for somebody who has 5,000 members for running experiments? Are there limits on how many we should run, or how should we be approaching that?
Yep, that's a great question. So even I wanted to caveat a little bit. Even though we have 500 million members, we actually have experiments that actually the randomization unit is actually not a member, right? So it could be a company, it could be a contract, which actually reduces our sample size in some of the cases to be thousands as well. So when you have a small sample size, I want to say number one, you should absolutely be running experiments as well. The reason is because when you are in the earlier phase of your development or your acquisition of members, you are looking for bigger impacts, right? Like for example, like today, even if actually we have like a 1% improvement on one of our key metrics is huge, right? Because the multiplier is huge, right? So we are looking for small changes. And then, but in your case, because your member base is small, you're looking for bigger changes. And then even if you have a small sample size, you should be able to have enough power to identify or to detect those big changes, right? So this is number one. Number two, it's actually when you are running with smaller sample size, sometimes the variance can kill you. So so variance reduction becomes pretty critical. So there are several techniques out there that you can do to reduce variance. Probably the simplest one is stratification. So you just wanted to make sure that your treatment group and your control group are evened out in terms of some of the key attributes you're looking at, right? So let's say, for example, you don't want it to be accidentally, by chance, your treatment group has more heavy user than your control group to start with, right? So you do stratification. There are some other techniques. We actually have a paper on how we can use pre-experiment data to reduce the variance when you are running the experiment. You can look it up. It's a wisdom paper, I think in 2012 or 13, I forgot. Yeah, and then so you have those techniques out there that you can use to essentially reduce the variance. Yeah.
Okay, so I have a question. I know you showed a page where you did the logging homepage test for LinkedIn, and it was like A/B test on, and I see the page changed quite a bit, right? So my question is, if you continue only do A/B test, 2 at a time, with all the change you have to run it for a very long time and multiple experiment. I don't think that's the best way. Even if you say you do a split testing, you increase like AB to ABN, or even you do multivariate, let's just say you have 10 things changing, 2 to the power of 10, that's many, many cells. So do you use other techniques, which is not shown here, to do that kind of experiment?
So when you say other techniques, like, are you referring to like, do we use like observational data to do causal inference as well? Is that what you're referring to?
More like kind of dynamic, like maybe like Bayesian-based multi-armed method.
I see.
Yeah.
Got it. So we actually, so number one, because a lot of our experiments are actually orthogonal, like I mentioned earlier, and then there are actually very little interference that happens between the tests, you can actually analyze the test independently as if there were no other tests that are running, right? So from scale standpoint, it's not really hurting us. So going back to the second question, which is the way that I'm interpreting is like, do we do like multi-embedded? We do a little bit, we don't do much. The reason with, I'm not sure whether, like, how many of you actually are familiar with the multi-embedded approach, which essentially, let's say you have a criteria that is set up. You have a treatment and control, right? And then essentially, at a given time, like periodically, you are checking how much traffic you should be giving to one arm versus another arm. Until sort of like one arm overpowers another one, right? And like it's essentially if everything goes well, if your criteria is good, then you eventually arrive at the arm that's generating more revenue or something like that, right? So the reason that we don't do that the reason that it has very limited application is because it's tricky. The metrics are tricky. So we actually, I had this example when I was at Bing, Microsoft. We had an experiment. So the experiment was actually had a bug in it. So what it did is basically ranking really poor results to the top of the page, right? So at the time, Bing had success metrics would be what? Query share, which is number of queries that people do, and then 2 is revenue. Both of these metrics went up. Because if you have poor results on the top, guess what people are going to do? People are going to click on ads, right? And also, if you have poor results on the top, people couldn't find what they're looking for. They keep on reformulating their query, right? So you can see that sometimes metrics can be very misleading. And you actually do need that intuition in terms of, hey, what is my experiment doing? Is it supposed to be impacting revenue? Is it supposed to be increasing revenue? Is it supposed to be increasing queries, right? And then that actually applies to a lot of our experiments. And like even more common is that a lot of our experiments sometimes increase one matrix and drop another one. And you do actually need, to some extent, a human intervention to be like, okay, like how is it doing, right? And then obviously we also have tons of experiments that's not supposed to be impacting metrics, right? And in that case, you also cannot really use the multi-embedded approach to do that. Now we use it for like some like relevance experiments that is very straightforward, that they're optimizing towards this one metric, and they know what this experiment is doing, and the criteria is very clear. Make sense?
I have a question about one of your slides where you were talking about the gain on a website and then extending it to a larger worldwide site. Could you please shed a little bit light on that? Like, suppose your experiment says, I mean, the improvement has been 10%, and you have like based on the p-value, it is statistically significant. How do you estimate the gain?
Mm-hmm.
Do you estimate the PDF?
Yeah. The question is that I talk about the triggered impact, and then I talk about how from there we derive at the sidewide impact, right? And the question is, how do we do that?
Exactly.
Yeah.
Forgot the term.
Yeah. And it's actually very simple, very, very simple. So let me just intuitively, this is what's happening, right? Let's say you run an experiment and you are impacting tech industry only. Let's say you're saying, okay, my experiment is impacting tech industry only. And then we know that tech industry, let's say, is like 10% of total LinkedIn population. And then even if you have 100% increase on sessions for tech industry, we discount it because it's only 10% of the total population, right? But of course, reality is more complex because guess what? Tech industry are heavy user, and then they behave a little differently, right? So you just kind of take those into consideration as well, and then just like multiply it out.
Okay.
And then we have it in our paper. If you, yeah, so you can look it up. I think it's the 2014 or 2015 KDD paper. Yeah. Mm-hmm.
Thank you.
So I came in. Oh, that's loud. I came in a little late, so I apologize if you already covered this, but you were talking a little bit about auto ramp and ramp recommendations. What are the specific actual ramp recommendations that you guys are making, and how did you tier that out in terms of saying this is what the ramp rate should be for this given risk level of experiment?
Yep. We actually we have a paper, but it's in progress. It's not done yet. I can if we get it into the conference we want, I can share that with you, I guess. So the concept actually like behind the ramp recommender and auto ramp is actually very simple, very intuitive. It comes down to the fact that we really understood, at least this is what's happening at LinkedIn, I think it should apply to a lot of folks who run experiments as well, is when you are running an experiment, depending on which phase you are in, you are either try to minimize the risk that this new launch is doing, or you try to measure how good your product, your new feature is doing, right? So if you're thinking about, you started ramping your experiment at a small ramp percentage, and ramping it up. In the early phase, your primary goal is to minimize risk. Then you get into this measurement phase. Actually, one of the tips for variance reduction is if you have 100% of traffic at your disposal, what is your, how should you divide that traffic such that you have the smallest variance? You should divide it 50-50, right? So again, the same thing. That's why we call you have this maximum power ramp that you should use to essentially measure your experiment. And that's also the ramp where you should keep your experiment running for the longest time. In our case, we actually recommend 1 week. And then once you go beyond 50-50, let's say assuming 50-50 is your maximum power ramp, then again, your goal becomes risk mitigation again. Because what you worry about is like, hey, maybe my service cannot handle that extra QPS, right? Until you reach 100%, right? So once we can actually divide up the phases of the experiment ramping process, then it becomes very easy when you are thinking about criteria to ramp experiment, right? So if you tell me that your experiment doesn't have any risk, or if you don't think it has any risk, I can actually go faster, right? And I can actually start maybe ramping your experiment at 10%, let's say, right? But if you say, hey, my experiment is actually risky, then I will start lower, but as soon as I measured that there's no risk or the risk is small enough, then you can go up, right? So it kind of becomes a sort of step-by-step process. Does it make sense?
Is the risk a human-defined thing, or do you guys have criteria on what is risk and high risk and low risk?
Yeah, so the high risk and low risk, there are a couple of things. One is actually sort of operational risk, right? So a lot of our changes don't impact the services, right? Like you may be making some UI changes or something like that, right? And so that's one component. The second component is actually in terms of how much do you think this feature is likely to be impacting metrics, our business metrics, our product metrics, right? And user engagements. So if you think it's impacting those metrics, and if you think that's impacting important metrics for the company, right? That's where we call tier 0, tier 1 metrics, then automatically you would be a high risk experiment. Yeah.
Hello, thank you. So a question about kind of how you calculate the stats during that ramp up period. So you start at 10% and then you go to 20% and 30% later. Are you calculating the stats just for the time period when it was at 10% and then just for the time period when it was at 20%?
Yep.
And then do you shuffle in between, or is that 10% going to stay in that variant into that 20%?
You can shuffle in between, and then sometimes we do because we have some residual impact that we didn't want it to keep. In almost all our cases, you just continue with the same ramp. The reason is because a lot of our changes involve UI changes, and we don't want it to be like, hey, you have this whole new experience today, and then tomorrow you get randomized into a different set, right? And the reason that we don't combine the impact all the way from the earlier ramps is because we can combine it. It's just like harder to get it, and like it's more expensive to get it right. Because if you just do it naively, you get into this what's called like Simpson's paradox. Yeah, exactly. So that's why we don't do it that way, and we don't really see much of loss either by doing that.
I think we're gonna cut off questions for now.
Thank you so much, Ya. I really appreciate it. And thank you so much, everyone, for coming. I want to express, I'm incredibly grateful to our advisor, Ya, as well as our customers, VEVO, for hosting us. I want to finish up with one thought. The hottest news in tech today is, have you heard of the Twitter news that they are now allowing you 280 characters? And do you also realize that's actually an experiment? Some of you have 140 characters, the rest of us have 280 characters. So please use that power to go tweet about experimentation, Ya, VEVO, and please split as well. So thank you very much, appreciate it.